Happy morning, my dear children. Today we are going to discuss about the chemistry, lesson number 11, fundamentals of organic chemistry. Okay, I hope that the previous sections everything is over. Remaining only somewhat we have having. That's the remaining portion is about that isomerism. Okay, what is that? Isomerism. Here, what is about the isomerism? The compound having same molecular formula but different structures, maybe some physical properties or chemical properties having some difference. That we are saying the isomerism. Compound having same molecular formula. A compound of the molecule or maybe a compound having the same molecular formula but different in the structure are called as what? Isomerism. Here, the isomerism can be, or isomers can be classified into two types. One is about that constitutional isomerism and another one is the stereoisomerism. Constitutional isomerism and another one is the stereoisomerism. What is about the constitutional isomerism? A compound having the same molecular formula but differ in their bonding sequence. They have some bonding, differs in their bonding sequence are called as a constitutional isomerism. They are again classified into number 1, chain isomerism, number 2, position isomerism, number 3, functional isomerism, number 4, metamers, number 5, tautomers, and also the last one is about the ring chain isomerism. These are all the different types of isomerism. And about the stereoisomer, they are again classified into two types. One is about that geometrical isomerism and another one is about that optical isomerism. Okay. I hope that these are the important questions. We have the 12th standard also having the chain isomerism, especially it's very important for the functional isomerism and the metamers. These are all everything are the important. So try to learn these questions. Okay. Anyhow, we can be discussed one by one. One is about the chain isomerism. A compound having the same molecular formula but differ in the arrangement of carbon skeleton. Okay, if they are differ in the same molecular formula, the number of carbon chain is entirely different. We can be say the given correct exact definition for the chain isomerism. What is about that otherwise called skeletal isomerism? Differ in the nature of carbon skeleton. For example, one of the examples is compound having the molecular formula is C5H12. This is one of the compound having the molecular formula C5H12. Here I am writing one of the compound that is CH3, CH2, 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 CH3. Okay, because number of carbon, how much number of carbon is there? 5 carbon. So 1, 2, 3, 4, 5. How much carbon is there? 5 carbon. When we can count the hydrogen, how much hydrogen is there? 12. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 3, 12. So the compound having the same molecular formula. Here, what is the name of this compound? We can be say a pentane. What's the name of this compound? Pentane. Am I right? Because having 5 carbon, we are saying the alkane name is about the pentane. Now, having some change, what is that change means? CH3, CH, CH2, CH3, CH3. This is another compound having the same molecular formula. What is about the formula? Hydrogen, carbon, 5, 1, 2, 3, 4, and 5. 1, 2, 3, 4. Okay. And about the hydrogen, how much hydrogen? 12 hydrogen, 3 plus 4, 6, 9 and 12 hydrogen. Okay, how can you say the name of the compound? Here you have the second carbon having methyl group. So the name of the compound is 2-methyl butane. What's the name? 2-methyl butane. Okay, from the near the methyl group we are starting the number 1, 2, 3, 4. So 2-methyl butane. One more compound we can write. One more compound. CH3, 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 CH3. We can be say the name of the compound is neopentane. Can we use the number? Number start with number 1. 1, 2, 3, or 1, 2, 3 like that. Second carbon having methyl and another one also having methyl. So the name is 2, 2 methyl, dimethyl, 2 dimethyl propane. What's the name? 2 dimethyl propane. Okay, dear children, here what do you understand about this concept? What do you understand? First compound having, it's a linear arrangement of this compound, linear arrangement, that is a straight chain compound, am I right? So here having number of carbon is 5, here also having the number of carbon is 5, here also having the number of carbon is 5. But anyhow, these are all compound having the same molecular formula, but the structures are different. The carbon arrangement having a different carbon arrangement. Here having the linear chain having the 4 carbon, one is methyl will be separated, and also here also 3, 4 sides are arrangement carbon. So the entirely the 3 compounds having 3 different structures. So we are saying the chain isomerism. Next about the second one is about that position isomerism. Position isomerism. What is about the position isomerism? The compound having the same molecular formula. Formula is same but differ in the position of the functional group. Otherwise, position of the we can say the unsaturated linkage. Position of the functional group. Otherwise, we can be say unsaturated linkage. Otherwise, we can be say the position of the substituent. Okay, same molecular formula. For example, what is an example means? CH3, CH2, CH2, CH2. You can take CH double bond, CH3. Example, name of the compound is, here double bond having first carbon, 2, 3, 4, 5. So 5 carbon means we are saying pent. Am I right? Pent. First carbon having double bond, so we are saying pent 1E, am I right? Suppose the position, this double bond comes to the second carbon. This double bond now present in the first carbon. Suppose it comes to the second carbon. So what is the formula of this compound? CH3, CH2, CH2, double bond CH, CH3, am I right? So the second carbon having double bond 1, 2. So what's the name of this compound? Pent 2E. Am I right? Pent 2E. So what is about the position isomerism? The compound having the same molecular formula but different in the unsaturated linkage. Unsaturated linkage. Here unsaturated double bond. The double bond first carbon having first place the double bond. Second compound, the second place is the double bond. Okay, this is about the position isomerism, and also we can change the substituent. And one more example. Another one example. CH3, CH2, CH2, CH2. One of the substituent is called as a chlorine. Am I right? So what is the name of this compound? First carbon having chlorine. 1, 2, 3, 4. So what is the name of this compound? First we have to say the name of the substituent. That is chlorine, am I right? 1 chloro. 1 chloro. Number of carbon how much? 4. Number of carbon how much? 4. So we are saying 1 chlorobutane. What's the name of the compound? 1 chlorobutane. Suppose this chlorine is attachment to the second carbon. Okay, suppose the chlorine is attached to the first carbon. Suppose the chlorine is attachment to the second carbon. So what is the formula? CH3, CH2, CH2, CH, Cl, CH3. Am I right? The chlorine is present on the first carbon. Suppose it is attached to the second carbon means it will become like this. Okay, am I right? So we have to use the number starting with here 1, 2, 3, 4. I'm taking here 5 carbons, so make it a 4, CH3. Okay, say the number. 1, 2, 3, 4. Second carbon having chlorine, so the name is 2-chloro. 2-chloro, number of carbon 4, the name is called as a butane. Okay, so this 2 compound having the same molecular formula. This 2 compound having the same molecular formula. But what is the difference? The position of the substituent is different. Okay, here the first compound, the substituent is present on the first carbon. The second compound, the substituent is present on the second carbon. That we are saying about the position isomerism. Which isomerism? Position isomerism. Next is about the functional isomerism. Okay, what is about that? Functional isomerism. The compound having the same molecular formula. Okay. The compound having same molecular formula but different in the functional group. We can be say the different functional, very important question about the functional isomerism. Okay, very important. Try to learn this question. Functional isomerism. Compound having the same molecular formula but different functional groups. Okay, different functional. Let us have taking one small example about the functional isomers. How can I explain this? The compound having the same molecular formula, that is C2H6O is a very good example. C2H6O. I am writing here, by using this formula, I am writing 2 functional group. How much functional group? 2 functional group. One is CH3, CH2OH. Next one compound I am writing CH3, oxygen, CH3. Listen all of you, here having 2 compounds, one is called as an alcohol. A compound having OH group is called what? Alcohol, am I right? A functional group, a compound having OH group is called as an alcohol. And a compound having an oxygen group, one oxygen group is called as what? It's a ether, am I right? Ether. So 2 functional group, one is an alcohol, second one is an ether, am I right? Cool. Here we can count the number of carbon. How much carbon is there? 2 carbon. 1, 2. Am I right? Here also having how much carbon? 1, 2. Am I right? So 2 carbon is there. So how much hydrogen is there? 3 plus 2, 5. 5 plus 1, 6. So hydrogen is also correct. About the oxygen, how much oxygen is there? Only 1 oxygen is there. So a compound having OH group is called what? Alcohol. Am I right? OH group is called what? Alcohol. And the compound, this compound we can be balanced here. How much carbon is there? 2 carbon. How much hydrogen is there? 3 plus 3, 6 hydrogen, and also having 1 oxygen. So anyhow, these 2 compound having same molecular formula. Which one is correct? The same molecular formula, but the different functional group. Am I right? Different functional. First one functional group is OH. The second one functional group is what? Oxygen. Am I right? So the compound having same molecular formula is same, but the functional group is different. Am I right? So what's the name of this compound? Simply we can be say the common name is, all of you know that one. It's an ethyl alcohol. Am I right? Ethyl alcohol. Ethyl alcohol. This we can be say dimethyl ether. Am I right? Dimethyl ether. Dimethyl ether. The first one is ethyl alcohol. So what is the IUPAC name of this compound? IUPAC name of the compound. First carbon having OH. So we are saying ethanol. Am I right? Number of carbon is 2. So 2 we are saying the alkane name root word is eth. Am I right? Eth. Root word is 2 carbon. Root word is eth. 1 carbon. Root word is meth. Am I right? Meth. 2 carbon eth. 3 carbon prop. 4 carbon bute. Am I right? So the 2 carbon we are saying eth. Here having single bond ANE. And the functional group OH. The secondary suffix, we have to say OL. Here, E is dropped, am I right? E is dropped. So the name of the compound is ethanol. What is the name of this compound? IUPAC name is ethanol. What second compound? Diethyl ether. Ether can be say methoxymethane. Am I right? Meth, one carbon meth. Here functional group is O, so we have to say oxy, one carbon methane. Am I right? So what's the name? Methoxy methane. So very important. As per our textbook, what is the functional group means? You are taking a compound having molecular formula C3H6O. Am I right? What's the formula? C3H6O. C3H6O. So we can write CH3, CH2, CH2. Am I right? CH3, CH2, CHO. Here, what's the name of this compound? How use the number 1, 2, 3. First carbon, am I right? Second carbon, third carbon. Propanol. Why the propanol becomes 3 carbon? The root word is prop. Am I right? Prop. 3 carbon root word is prop, and having single bond ane, and having CHO group means we are saying aldehyde. For the aldehyde, secondary suffix is Al. Am I right? Al. So E is dropped here. So what's the name? Propanol. Okay, propanol. So one of the compound is about an aldehyde, and another one compound I am taking this CO to the center of this group, CO to the center of here, and hydrogen is attaching here. Am I right? CO, one of the another functional group is called aceto group, keto group. Am I right? So this hydrogen is attaching to the CH2 groups. So CH2 is converted into CH3. Yes or no? Here the hydrogen is attaching to CH2. So the CH2 is converted into CH3, and the CO is a functional group come in the center. So we can written CH3, CO, CH3. Am I right? CH3, CO, CH3. So this is the aldehyde group. This is a keto group. Am I right? The name of the compound ketone. Okay. Otherwise it can be say acetone. Dimethyl ketone. Dimethyl ketone. Otherwise acetone. What's the name of the compound? This is a common name. Dimethyl ketone. Otherwise acetone. Yes or no? So what is the IUP is the name of this compound? Number of carbon, how much you having? Number of carbon? 3. Propane, am I right? Propane. Suffix also I am writing. Primary suffix, propane. 3 carbon is propane. So functional group CO is there. So the secondary suffix is 1, am I right? On. So propanone, ONE, am I right? Propanol. What's the first compound? Second compound is a propanone. So here what do you understand about this area? About that compound having the same molecular formula but different functional group, that we can be say as a functional isomerism. Compound having the same molecular formula but different functional group. First compound having the functional group is an aldehyde. The second compound, the functional group is an keto group. Am I right? This is about the functional group. Don't forget that functional isomerism. The next one is about that metamers. What is about the metamerism? Metamerism. The compound having the same molecular formula but different unequal distribution of carbon atom. Unequal distribution of carbon atom. Simply we can write, this is one of an oxygen. Oxygen is one of the functional group. The both the side of this oxygen, different alkyl group is attached. Am I right? Different alkyl group is attachment. Different alkyl group. Maybe we can be written as R, O, R dash, like that. Different alkyl group. R refers to alkyl. For example, alkyl means methyl, propyl. butyl, etc., etc., etc. Am I right? So different alkyl group is attaching. That isomerisms are called as we are saying metamers. Example, C4H10O. C4H10O. This is one of the compound having the molecular formula. What's the formula? C4H10O. So I am writing one of an example. CH3O, CH2, CH2, CH3. Okay, this is one of the compound. Next compound I am writing, this oxygen go to a center. So what's the compound? This oxygen go to center means CH3, CH2O, CH2, CH3. Am I right? Yes or no? Now the oxygen is goes to center. One more compound I am taking, one of the branched compound I am taking. That's CH3O, CH, CH3, CH3. Yes or no? So, as per this formula, I take three compounds. First compound, the same molecular formula. How much carbon is there? 1, 2, 3, 4. How much hydrogen is there? 3 plus 2, 5, 5 plus 2, 7 plus 3, 10. So, everything, the same molecular formula and also having one more oxygen. So, these three compounds having the same molecular formula and we can be say the same functional group. But one is the different. The both two sides having different alkyl group. Am I right? Here having one methyl group, here having propyl group. Am I right? Here having ethyl group, here also having ethyl group. Am I right? So here also having methyl group, here also having one isopropyl group. Am I right? So different alkyl group is attachment to the each side of the oxygen atom. That we are saying in metamers. Yes or no? So, but how can you say the name of the compound? Here one of the methoxy group is attachment to the propane, am I right? Methoxy group. So how can you say the name of the compound? Number, we are using the number 1, 2, 3, am I right? So first carbon having methoxy group. Which group? First carbon having methoxy group. So what's the name of the compound? 1 methoxy propane. What's the name? 1 methoxy propane. 1 methoxy propane. Am I right? What's the name of this compound? Ethoxyethane. What's the name of the compound? Ethoxyethane. What's the name of this compound? Here we use the number 1, 2, 3. So, second carbon having methoxy group. Am I right? Second carbon having methoxy group. So we can be say 2 methoxy, 3 carbon means propane. Can you understand? What is about the first one? First carbon having methoxy group. Second carbon having first carbon having methoxy group. So the name can be written as 1 methoxy propane because number of carbon having 3. So we are saying propane. The second compound, here also having ethyl group, there also having ethyl group. Ethyl group can be said as eth. Okay, ethoxyethane. So oxygen group, how to say oxy is a secondary suffix oxy. So OH means we can be say the secondary suffix is OL. CHO, the secondary suffix is EL. Am I right? So oxygen we can be say oxy. Okay, CO, ketone or acetone can be written as on. These are the secondary suffix. These are the secondary suffix. Don't forget that. Okay. So anyhow, what is the first compound name? 1 methoxy propane here. Ethoxyethane here. 2 methoxy propane. These are all what? About the metamerism. Next about the tautomerism. Okay, what is about the tautomerism? Okay, here, the compound having the same molecular formula. The compound having the same molecular formula. Here, this compound can be exist interconvertible. This one compound can be converted into other compound can be converted into the first form can be converted to second form can be converted to other form. Am I right? So it can be interconvertible, readily interconvertible. Okay, here we can say two different structures. How much different structure? Two different structures. Here having classified into two types. One is about the Triadic system. Triadic system is a two. That means hydrogen is oscillate between two polyvalent atoms. Hydrogen is oscillate between two polyvalent atoms. For example, hydrogen. See, cyanide. Hydrogen cyanide. Here, hydrogen is attached to the carbon. Am I right? As per the correct way we try to hydrogen C triple bond here. Can you say why we are using triple bond here? Because the carbon valence, am I right? Carbon valence is 4. Everyone know, am I right? 1, 2, 3, 4. Am I right? So here the hydrogen is attachment here. This we can be say as that one hydrogen cyanide. Hydrogen cyanide. Am I right? What's the name of the compound? Hydrogen cyanide. The second one is when the carbon is going outside, nitrogen is coming here. So what is the formula? HNC. Am I right? So here the bond is having some problem. Am I right? Here nitrogen giving an electron to here. Nitrogen. Because the atomic number of nitrogen, what is the number here? We try to say here arrow mark mentioned here as an arrow mark like that. Nitrogen giving an electron to the carbon. Am I right? One pair of electrons. So we are using as an arrow mark here. Okay, coordinate one. Am I right? So anyhow, this is the actual form. Hydrogen, nitrogen, cyanide. Okay, carbon. So here, how can you say the name of this compound? With the hydrogen isocyanide. Hydrogen isocyanide. First one is a hydrogen cyanide. Second one is a hydrogen isocyanide. This is a Triadic system. Am I right? So here, what is the meaning means? Hydrogen atom oscillate between two directly polyvalent atom. Am I right? Here carbon and nitrogen. Carbon and nitrogen are the polyvalent atom. Here hydrogen atom is directly linked with first compound having hydrogen is attachment to the carbon. Second compound hydrogen is attachment to the nitrogen. Am I right? First compound having hydrogen is attached to the carbon. Second compound hydrogen is attachment to the nitrogen. So we are saying the polyvalent compound. Am I right? Polyvalent atom. So this is about the Triadic system. Next one. Next about that, last one is about the Triadic system. About that, the hydrogen atom is attachment to the three polyvalent atom. Here hydrogen atom is attached to the two polyvalent atom. Here hydrogen atom is attachment to the three polyvalent atom. For example, acetaldehyde CH3 CHO. Am I right? This can be written as HCH2 Z double bond O hydrogen. Am I right? Here the first hydrogen atom is migrate to the, this is the first carbon, first compound, first polyvalent compound. This is the second one. This is the third one. So this hydrogen is migrate to the third polyvalent atom. That is about the Triadic system. Triadic system. Okay. And one more form also having. Okay, my dear children, try to learn this area. You have to read it, and I am my humble request to write anyone that is a functional isomerism about the assignment. Okay, this is the functional isomers. So don't forget that. Try to write and send to me. Okay, thank you all of you. Thank you. Have a nice day.